Mass transfer is the net movement of mass from one location, usually meaning a steam, phase, fraction, or component to another. Mass transfer occurs in many processes such as absorption, evaporation, absorption, drying, precipitation, membrane filtration, and distillation. Drying cloth involves two processes. Energy has to be provided to change the water from liquid to vapor, and as rain is needed to remove the vapor.
When a system contains two or more components whose concentration was vary from point to point, there is a natural tendency for mass to be transferred, minimizing the concentration difference within the system and moving it towards equilibrium. The transport of one component from a higher region to that of a lower concentration is called mass transfer. In mass transfer, there are four types of unit operation. There are diffusion, distillation, absorption, and extraction. All of them are dealing with the separation process. Diffusion is one of the most common processes in mass transfer. It is the spontaneous movement of substance from a region with high concentration to region with low concentration. This is also referred to as the movement of a substance down a concentration gradient. A gradient is the change in the value of quantity between in other variables. In this experiment, the diffusion unit operation is taken place between the water soap and clothes during the process of removing dirt. Soap is a substance used for washing and cleaning purpose, consisting of a mixture of sodium or potassium salt or of natural occurring fatty acid. The reaction produces sodium salt of this fatty acid, which improves the cleaning process by making water better able to lift away excess stain from skin, hair, and clothes. Soap often contain coloring matter and perfume and act by emulsifying grease and lowering the surface tension of water so that it more quickly penetrate open materials such as textile. In mass transfer technology, the laundry process will undergo the distillation process. It is whereby when the soap was added to the pile of water and clothes, the soap will then disperse while water acts as a medium transport it. The soap molecule is then being absorbed by the dirt on the surface of the clothes. The process continues until the concentration of the soap in the dirt was in equilibrium, which enables it to come off from the clothes as the soap molecule has less than the water.
Nowadays, drying clothes usually use natural way by using energy from sunlight and wind. Several factors that determine the duration of drying, such as the environment temperature and humidity of surroundings. The objective of the experiment is to determine the volume and mass of the shirt after drying process done on outdoor and indoor. The time taken for the experiment is set for 6 hours. When the drying process is done inside of the house, the absence of heat has prevented the evaporation process from occur and increasing the duration of the drying process. As the clothes left outside of the house, the evaporation process occurs. The presence of heat will decreasing the duration of drying process as moisture will lose to surrounding more quickly.
Okay, so I'm gonna show you how we're gonna dry clothes inside the house, which is indoor. So we take the wet clothes. As you can see, there's a lot of water absorbed by this clothes. So I'm gonna hang this clothes by using the hanger inside the house. A lot of water being absorbed by this shirt. So I will take the bed. I will put it into the shirt. So at the end of the experiment, we can see how much water that will be absorbed by will be collected inside this bed. So as you can see the surrounding side of the house, which is indoor. So there is no direct heat inside of the house, which is sunlight. So for this experiment, we only depend on the air humidity inside the house. So after 6 hours, we will observe the mass of the t-shirt and the volume collected inside the pail, and we will compare it with the other experiment which we do it outside of the house. As you can see, the condition outside the house is very sunny and also very windy condition. This will affect the drying time of the clothes. Today I would like to demonstrate on drying clothes outside the house. As you can see, the cloth is very heavy because of the water absorbed inside the pail. The pail is used to collect the mass and volume of water after the drying about 6 hours. This is the result of our experiment of the drying process after 6 hours. So on my left side is the yellow shirt, which is been drying outside of the house, and the blue shirt is been drying inside of the house. So from my observation, the yellow shirt is completely dry compared to this blue shirt, and the mass of the blue shirt is more heavier compared to the yellow shirt. So on the other observation, as you can see here, the water inside the blue pail is more if we compare it with the water inside the red pail. This is because the water in the red pail is the water inside the red pail is lost due to the evaporation process, while the water inside the blue pail is not lost because it only depends on the air humidity inside the house. So that is all.
Squeezing. Squeezing is an act in washing clothes which were usually done to decrease the amount of water content in the cloth before it is being dried. The process of squeezing will allow a big amount of water to be diffused out by force. Squeezed clothes will take a shorter time to dry rather than the unsqueezed cloth. This is different as the amount of water content by the cloth are rather high if it is not being squeezed before being hung. Furthermore, little amount of water will increase the rate of drying. Thicker cloth will have slower rate of water diffusion than the thin cloth. This is because the thicker cloth will act as a thick membrane which will allow a small amount of water molecule to be passing through. Rather than a thin cloth, there will only be a thin layer of membrane that would allow more water molecules to be passing through. Only small water molecule will be easily passed through a thick membrane, which is the cloth, while bigger water molecules will stuck until the size reduced, then will only be passed through. On the other hand, the thin cloth will be an easy way for either big or small water molecules to be passing through. This shows why thicker cloth will take a longer time to dry compared to the thin cloth. Weather. Weather plays an important role in drying of cloth. This is because the weather will determine the rate of drying and also relative humidity in the surrounding. In a hot weather, the relative humidity is lower and hence the rate of drying is higher. On the other hand, during the raining season or a cold weather which involve winter and cloudy, the relative humidity is at higher rate. Hence, the rate of drying which involves the diffusion of water are in slower rate as the amount of water molecules are not much of a difference between in the cloth and the surrounding. While during the hot weather, there are a lot of heat that will be absorbed by the cloth and water will be easily diffused out from the cloth. The darker the color of the cloth will increase the rate of drying of the cloth. This is because the light colors will reflect more light than the darker colors. When a colored fabric absorbs light, it turns the light into thermal energy. The more light the colors absorb, the more thermal energy it produces. Black fabrics will absorb all colors of the light and is therefore warmer than white fabrics, which reflects all colors. The colors of the spectrum appearing the darkest and most like black, such as violet, indigo, and forest green, will produce the most thermal energy. The other colors, such as red, orange, and yellow, will produce the least thermal energy because they appear lighter or more like white. Next is surrounding. Mass transfer is a continuous process which will occur until it reaches its equilibrium state. In drying, the process of mass transfer can be influenced by the relative humidity of the surrounding area. The rate of drying will become shorter when the cloth are dry in open air rather than in a closed room. This is because in an open system, the water molecules that have been diffused out will be free to the open air. On the other hand, the water molecule from the cloth that was dried in a closed room will stay in the system and causing the system to be at high humidity. This is relevant as a high humidity surrounding contains more water molecules. Hence, the equilibrium state will be faster to be achieved even though the clothes are not really dry. In addition, in an open air system, there is an air movement which produces kinetic energy that will help to transport the water molecules at a faster rate.